Somewhere in the Milky Way, there may be planets moving through the darkness with no sun above them. No sunrise, no sunset, no familiar star holding them in orbit. And here's the part that sounds almost impossible. Astronomers have evidence that these lonely worlds may be far more common than we once imagined. They're called free-floating planets, or sometimes rogue planets. Unlike Earth, they don't orbit a star. They're gravitationally bound to the galaxy as a whole, but they're not tied to an individual solar system. And scientists don't usually photograph these worlds directly. Instead, they catch them when their gravity briefly bends and magnifies the light from a much more distant star. That fleeting flash can last only hours. Then it's gone. In 2023, a major analysis of 9 years of observations from the MOA-2 microlensing survey found evidence for a population of free-floating or very wide-orbit planets extending down toward Earth mass. The researchers concluded that Earth mass rogue planets could be much more common than giant rogue planets. So picture the Milky Way differently, not as a galaxy filled only with stars and their orderly planetary systems, but as a cosmic ocean where countless worlds may be drifting between the stars. How does a planet become separated from its sun in the first place? And if a planet can survive after losing its star, what exactly happens to it next? Stay with that question, because the answer gets much stranger. And if you're fascinated by worlds hiding beyond what our eyes can see, hit like and subscribe for more cosmic discoveries. For most of human history, our mental picture of a planet was simple. A planet belongs to a star. Mercury belongs to the sun. Venus belongs to the sun. Earth belongs to the sun. Jupiter, Saturn, Uranus, and Neptune belong to the same system. Even planets orbiting other stars fit the same basic pattern. A star forms. A disk of gas and dust surrounds it. Small pieces collide and grow. Eventually, planets emerge and settle into gravitationally controlled orbits. It seems almost inevitable. But planetary systems aren't perfectly calm. Early systems can be crowded places. Newly forming planets interact gravitationally with one another. A giant planet can tug on a smaller planet. A passing star can disturb a system. Over long periods, these interactions can alter or even destabilize planetary orbits. And in the right circumstances, a planet can receive a gravitational kick powerful enough to escape its original star. Imagine Jupiter suddenly pushing Earth outward with a gravitational shove. Earth wouldn't simply stop existing, it would continue moving through space. The difference is that instead of following an orbit around the sun, it would follow its own path through the galaxy. That's one possible origin of a rogue planet. But there's another possibility. Some planetary mass objects may form in isolation, directly from collapsing clouds of gas, rather than inside a traditional planetary disk. And this distinction matters, because if some of these objects formed independently, then they're not simply failed members of ordinary solar systems. They could represent a different branch of cosmic formation altogether. Astronomers have already observed free-floating planetary mass objects in young star-forming regions. Some are several times the mass of Jupiter, although scientists continue to debate whether the smallest such objects formed like planets or like extremely low-mass stars. So here's the first mystery. Are rogue worlds mostly planets that were thrown out? Or are some of them born alone? Here's where astronomy gets wonderfully strange. How do you find something that doesn't shine? A rogue planet may reflect no nearby starlight and produce very little detectable light of its own. If it's old and cold, it could be extraordinarily faint. A normal photograph may simply show nothing. So astronomers use gravity. Einstein's theory of general relativity tells us that mass curves spacetime. When a massive object passes almost directly between Earth and a distant background star, its gravity can bend the star's light. From our perspective, the background star temporarily becomes brighter. This is called gravitational microlensing. And if the lensing object is a planet, the brightening can be extremely brief. That's the crack in the old picture. A planet doesn't have to announce itself by blocking a star's light. It doesn't have to make its host star wobble. It doesn't even need a host star. Its gravity can be enough. The MOA-2 survey spent years monitoring stars toward the crowded center of the Milky Way. The 2023 analysis examined thousands of microlensing events from observations collected between 2006 and 2014. Researchers identified very short events consistent with planetary mass objects, including events sensitive to masses around and below that of Earth. But there's an important scientific caution here. Astronomers often call these objects free-floating or rogue planets because they're not observed orbiting a star. Yet in some cases, a very distant host star can't be completely ruled out. That's why these discoveries are so valuable. They're not just pretty pictures. They're measurements of invisible gravity, and the shorter the lensing event, the smaller the object can be. That means the universe may contain a population of worlds that traditional planet hunting methods were almost never designed to see. Now imagine being an astronomer watching a computer screen as a star suddenly brightens. You know something has passed in front of it, but you can't see the object. You only see its gravitational fingerprint. The brightness rises, then falls, and the entire event may be over in less than a day. What would you think? A mistake? A faint star? A planet? Something else entirely? That's the challenge with rogue planets. The evidence is often indirect, and scientists have to separate genuine planetary signals from the enormous number of ordinary stars and other gravitational events crossing the field of view. The 2023 MOA-2 work was important because it wasn't simply looking for one spectacular object. It studied a population and estimated how frequently different masses appear among free-floating or very wide-orbit planets. The results indicated that Earth-mass objects may be more common than Jupiter-mass ones. That changes the story. For years, some of the best-known rogue planet candidates were huge, Jupiter-sized or larger. But what if the galaxy is actually full of smaller worlds? What if Earth isn't unusual because it has a star? But because we happen to live on one of the planets that still has one, there's also an important limitation. Microlensing is a one-time alignment event. Once the lensing geometry passes, the signal disappears. Unlike a transiting planet, you can't simply wait for the same planet to cross its star again. NASA describes microlensing as especially valuable because it can reveal worlds that other planet hunting methods struggle to detect, including planets far from stars and free-floating planets. And that brings us to the really big question. How many are actually out there? Early estimates already hinted that rogue planets could be surprisingly abundant. A 2011 analysis based on microlensing suggested there could be hundreds of billions of free-floating Jupiter-mass planets in the Milky Way, although later work has refined the picture and shown that the abundance depends strongly on planetary mass and on how these objects are classified. Then came the 2023 MOA-2 analysis. Instead of focusing only on giant worlds, researchers pushed toward much smaller masses. And suddenly, Earth-mass objects entered the conversation. NASA researchers reported that their analysis could imply an enormous population of rogue planets and suggested that NASA's Nancy Grace Roman Space Telescope could potentially detect hundreds of Earth-mass rogue worlds during its planned microlensing survey. NASA's current mission material describes Roman as a powerful tool for finding free-floating planets and says the mission is expected to investigate worlds ranging from planetary masses upward. But don't picture hundreds of Earths sitting conveniently close enough for us to photograph. That's not what this means. These worlds could be incredibly distant, and many may be extremely difficult to study after the microlensing event ends. So what might a rogue Earth actually look like? If it were ejected early in its history, it could lose the steady energy source that sunlight provides. Its surface could become unimaginably cold. But cold doesn't necessarily mean every part of the planet becomes frozen solid. Earth itself contains internal heat, generated partly by radioactive decay and leftover heat from its formation. A sufficiently massive rocky world could retain geothermal energy for billions of years. And beneath an insulating layer of ice, some researchers have considered whether subsurface liquid environments might persist under certain conditions. That doesn't mean rogue Earths are habitable. It means the absence of sunlight doesn't automatically eliminate every possible environment where chemistry could occur. And that's where this story becomes much more interesting. But then new data changed the scale of the mystery. The 2023 results suggested that free-floating planets may be much more numerous at Earth-like masses than at Jupiter-like masses. That's a major twist. Because giant planets are easier to detect in some ways, and they were among the first rogue worlds to attract attention. But if smaller planets dominate the population, then we've potentially been seeing only the brightest clue to a much larger hidden population. Think about the implication. The galaxy contains hundreds of billions of stars. And if rogue planets are abundant, there could be vast numbers of worlds moving through the dark spaces between those stars. NASA has even described a possibility in which rogue planets could outnumber stars by a huge margin, although the exact number remains uncertain and depends on the underlying population model and the definition of a free-floating planet. This is where we need to separate fact from speculation. Scientists haven't discovered trillions of individually confirmed Earth-like rogue planets. They haven't photographed an army of hidden Earths. Instead, researchers use statistical measurements from brief microlensing events to estimate a population. That's very different, and it's precisely why future observations matter. NASA's Nancy Grace Roman Space Telescope is designed to conduct a major infrared survey of the sky and use microlensing to discover planets that are difficult for traditional methods to find. NASA's current material says Roman could detect rogue worlds that don't orbit stars and could greatly expand our knowledge of these objects. So the next generation of astronomy may not just discover another planet. It could reveal an entire population that we've barely been able to count. If this blew your mind, tap like, because we're about to get to the physics that makes these invisible worlds detectable at all. But here's the open question I want you to remember. If billions of planets can survive without a star, what else could be hiding in the darkness between the stars? Maybe the next great planetary discovery won't be a world orbiting a distant sun. Maybe it'll be a world with no sun at all. If this changed the way you picture the galaxy, hit like. Subscribe for more stories about the strange worlds hiding in our universe. And tell me in the comments, would you rather visit a planet orbiting another star, or a rogue planet wandering completely alone?